Welcome back to Lecture 3 of Beginner's Guide to Understanding Chemistry, Atomic Symbols, and Isotopes. I should really call this Beginner's Guide to Understanding Psychedelics, because that's what we're building up our knowledge to do, but in doing so, we'll learn quite a bit of chemistry along the way. First slide, let's talk about atomic symbols or chemical symbols. We use abbreviations called atomic symbols to describe elements. Here's the atomic symbol for carbon. We see this number in the upper left-hand corner is a 6. This is called the atomic number, which equals the number of protons. And if you remember from our last lecture, we said the number of protons, or protons in general, are those particles in the nucleus of an atom that are positively charged. The atomic number corresponds to the box which the element appears on the periodic table. The atomic number is always the same. All carbon atoms have 6 protons. If you add a proton to this atom, we would have 7 protons. And when I have 7 protons, it is no longer carbon, it is nitrogen. Conversely, we could take away an electron and that would change the identity of the element. Case in point is that the number of protons will always be the same for the same element, and if we change that number, we actually change the element's identity. Inside each element's box, there is also another number called a mass number. It is located here on the bottom. In the case of carbon, it is 12.001. This refers to how much that atom weighs. We should note that we can change the mass number without changing the element. This changes the number of neutrons. However, we said before that we could not change the atomic number or the number of protons, as this does change the identity of that element. But changing the mass number does not change the element, it just changes the number of neutrons. Here's the formula. Mass number is equal to the number of protons plus the number of neutrons. This formula will be useful when I ask you guys to do some homework questions in the next few slides. Example, a carbon-6 atom has 6 protons, 6 neutrons, and 6 electrons. I should also mention that in a neutral molecule, the atomic number is also equal to the number of electrons. We'll see in some cases it's not, but for this case it is. So we have 6 protons plus 6 neutrons equals 12, but not all carbon atoms weigh 6. Another common weight is carbon-13. Carbon-13 has 6 protons, 7 neutrons, 6 electrons. 6 protons plus 7 neutrons equals 13. Conversely, carbon also exists as carbon-11, which would have 6 protons, 5 neutrons, and 6 electrons. 6 protons plus 5 neutrons equals 11. Keep in mind this formula will be useful in the next few slides. Keep it handy and try and remember it. As we just saw, an atom can have a different number of neutrons without changing the identity of that atom or element. We call this idea isotopes. Isotopes are atoms with the same atomic number, but different masses. This happens when the same atom has a different number of neutrons. Question: magnesium has 2 isotopes, magnesium-25 and magnesium-23. How many protons and neutrons does magnesium-25 have? And how many protons and neutrons does magnesium-23 have? Here is the symbol for magnesium. You should be able to use information from the previous slide to figure out the answer to this question. As I'm a strong believer in pen and paper style questions, you should take the time to answer the following questions pen and paper style at your own time. How many electrons, protons, and neutrons are in xenon? Here's the chemical symbol, and I will say for all of these examples, the number of electrons and protons will be the same. How many electrons, protons, and neutrons are there in uranium's isotope uranium-235? Here's the chemical symbol for uranium, which normally exists on the periodic table as uranium-238.